welcome. Now I'm going to illustrate the phenomenon known as capillary action. And capillary action is basically when a liquid is able to go against the force of gravity and rise in the opposite direction that gravity would have it go, right? Gravity would tend to want to make an object go down and a liquid go down. Well, we have the demonstration here as a simple demonstration. We have a tube with different diameters, right? And then it goes like this, and then the diameters keep getting smaller and smaller, right? The lengths don't necessarily have to get smaller. It could be the same length here. The diameter keeps getting smaller and smaller. And then finally you have a thinner one here. And then you have the thinnest one here like this. Okay, and then you fill this with some liquid, and you can see if capillary action didn't exist, the liquid levels should be the same no matter what the diameter of the glass is, right? The liquid level here, here, here should all be the same if capillary action doesn't exist, right? But what's going to happen is the narrower the tube, the cohesive forces between the liquid and the glass and the surface tension that is on the top of the liquid is going to cause the liquid to start going up higher in the narrower tube, right? So if we have with a different color here, we can show this one is going to be slightly higher, right? This one is going to be a little bit like this, right? It's going to move up the tube, but not as much. This one, the level is going to be slightly higher, and then this one, the level is going to be slightly higher, right? So then this is, the liquid is filling this whole region, right? Like this. And then this is going to be even slightly higher, and then this one is going to be even slightly higher, right? And then this is going to be the highest. And you can say, well, what is the purpose of capillary action, and does it have any good benefits? Well, actually it has a lot of benefits in biology, and it also has a lot of benefits in our homes. So like, let's say you take a towel and you want to clean, dry a table that's wet, and then you wipe it over the table. How does the towel absorb the liquid from the table? The liquid starts going into the molecular structure of the towel, right? And then it starts getting absorbed by the capillary action that is working against gravity, right? The liquid is being sucked into the towel. Same thing with a sponge. If you put a sponge long enough over the water starts going up to the molecular structure of the sponge. This is also used in biology by trees, by branching out and making their stems thinner and thinner, right? As the bark of the tree on the bottom, the trunk of the tree is very thick, right? And then as the tree branches out, it starts getting thinner and thinner, the diameter. Eventually, when it goes to the leaves, the diameter is the thinnest, right? With this way, the tree can draw up water from the roots up through the capillary action to the leaves, and then you can get essential nutrients to the leaves, right? And then this is also done by our biology, by our veins, and then by even the tearing that we do through our eyes to wet the eyes. This is all done by capillary action in biology, right? So I'm going to bring this up closer now. You can see. Okay, you can see here the water level is here. You see as I drew up there. You see over here the water level is slightly higher if you compare them. If you go across, it's a little bit slightly higher. The water level here, right, is slightly higher than this one. This is a narrower tube, right? So slightly higher. So this one, if I go across, it's going to be somewhere there slightly higher than that. This one, the water level is slightly higher than that. Actually, that one is a more significant difference. So the narrower, the more the effect is noticeable. This one, it goes like this, and it's quite bigger than that, quite higher. This one is very, very thin at the top. You can see the diameters from the top. You see this one is the widest, then it's getting thinner, then thinner, then thinner. This one, the diameter is very, very thin. Okay, you can see it's very thin. So if you look at the water level, it goes all the way up to the right here. It's kind of hard to tell. Here you can kind of tell it's right here, and this one is right here. See the edge, it's so thin, way, way higher than the water level here. It's like right there. You see? So now it's being really pulled up by the capillary action of the adhesive forces. And you can see here how this can be used by biology and by sponges and towels, and all the kinds of suction devices that we use rely on capillary action. Okay? Thank you very much.